Hey, welcome to the next video. So we learned all these four actually number systems, which are decimal, binary, octal, and hexadecimal. We summarized everything up in the previous video, and but actually octal is not being used so often in the computer system. However, we are going to deal with decimal, binary, and hexadecimal, all these numbers all the time when we are programming with a microcontroller or when we're designing a computer logic system. So we have to understand what are these numbers and how to convert from one to another. So let's take a look at these three number systems: binary, decimal, and hex. Okay, how can you convert a binary number into a decimal number? And how can you convert a binary number to a hex number? And how can you convert a decimal number into a hex? And how can you convert these numbers back as well? These are pretty important, and we are going to go through these conversions for this lecture. Let's see if we can get it done in 20 minutes or something. So you know how to convert between these three number systems, and so you can do the homework. Okay. So now let's take a look at the binary number. So before we do that conversion, I just want to show you the concept for this. So if you look at the example of the decimal number, for example, 537, let's say this is a 10-based number, which is a decimal number. Okay. So what does that mean here? So these three numbers being put together to form one number, we know it's going to be 537. But actually, if you only look at one single one every time, it's not 500, it's just 5, right? In Arabic numerals, it's just 5, and this is just 7. This is just 3. This is just 7. However, if you put them together, then they are at the different locations. This 5 here is not 5 anymore. However, it's going to be 500. So this number, if we separate all these 3 digits, it's going to be like this: 5 times 100, which is this number, plus 3 times 10 plus 7 times 1. Because 7 here means 7 ones, 3 here means 3 tens, and 5 here means 5 hundreds. Okay, and if you add them together, you can recover this number as 537 in a 10-based number system. Right. So we can write it down in another form like this: 5 times 10 to the number of 2 plus 3 times 10 to the number of 1 plus 7 times 10 to the number of 0. And this is also 537. So if we have a binary number like this, okay, and probably you couldn't eyeball it saying like, what's this number? You don't know, actually. However, let's convert into a decimal form version so you know what's this number. And here 1 represent 1. But however, this digit means it's 2 to the times 0. It's the same as a decimal number here. This digit, every number here represent how many of 10 to the number of 0, right? So this here in binary number system is a 1 times 2 to the number 0. And then this digit represents 0 times 2 to the number of 1. And this digit is 1 times 2 to the number of 2. And here is 0, and then add another one, Okay, this is how you split all these digits and put them together, and now you can recover this number. And now let's take a look at that. If this number is this one, so here this is 16, and here is 0 times this is going to be 0, and 1 times this is going to be 4, and 0, and this is 1, right? So the final A is going to be 21. And now let's see if this is right. Okay, if I grab a calculator here and I use programming version, and if I put a decimal 21 here, and now let's take a look at the binary version. It's 10101, right? 10101, so which is correct. And now this is how we convert. We know this is a decimal number, so we already have the first conversion done here, which is from binary to decimal. Right. So which is this part. Okay. So for the rest of the time, we just need to figure out all these other conversions as well, right? So now this is for number 1 binary to decimal. So now let's take a look at another example here. For example, 100. We know this is a binary number and we want to convert it into a decimal number. So 1 to the number of. So here's a tip, right? Just count how many digits does this number have, after this digit. So there are 2, so it's going to be 1 times 2 to the times of 2, and plus 0 times 2 to the time of 1, 0. Okay, because this number here, after that number, there's only 1 digit after it, so we put a 1 here, and this one there's nothing after that, so we put a 0 here. Okay, so finally this is 4 plus 0 plus 0 is going to be 4, and we know 100 is going to be 4, right? So let's verify that really quick. So if we put a 4 here, you can read it here from in the binary version. It's going to be 0100. So we put a 0 in the front. It doesn't matter. It just want to. So this one just want to form a 4-bit binary system. Okay, you can put as many as you want in the front, which won't affect the result. Okay, 0100 is going to be 4, and 00100 will be 4 as well. That won't change the value of the number. Okay, so that's the first conversion. So now let's keep going. So binary to decimal. What about binary to hex? Let's do it. Binary to hex. One zero one zero one, the same number. So what's the hex number of it? So the tips here to convert a binary number into a hex number is we group all the binary digits into 4s. For example, here we have this one, 4 digits, and this one, is just 1 digit. However, we can make up 3 zeros in the front, which won't affect the result, and make a 4-digit here. And now you just write down this 4 and this 4 as a hex form in here. So it's going to be the hex number for it. So this one is actually 1, and this one is 5. So you do have a 5 in hex. So that's final hex version for this number. Okay. Now let's look at another one. For example, 11110111. That's a binary number as well. So what's the hex version for that? So as usual, we group all these binary digits into 4s. So we just have 8 digits, so which is evenly divided into 2 halves. And now 111 is going to be 15, and we know 15, so that's 15. 15 in hex is actually F, right? And this is 7. 7 is still 7. We just write it down here. So you group these binary digits into 4, and then actually you start grouping them from the right side. If you do not have enough zeros, just make up 0 in the front. Okay, this is how you make it. How you convert a binary number into a hex number. All right. So anything start from a binary has been done. So binary to decimal, you know how to do it. Binary to hex, you know how to do it. And now what about third one? Decimal to hex. How to do that? So this is a little bit tricky, and let's come back here after we are done with the decimal to binary, okay? And then we'll start dealing with this one. So now let's do it later, okay? Decimal to everything is a little bit tricky, but we will get it done. Don't worry about that. So decimal to hex, number 4 will be decimal to binary. So when you convert anything from decimal, it start getting more complicated. So let's do it later. Same thing, okay? So what we are going to do after this one will be hex to binary. Right, this is pretty similar to binary to hex. So from binary to hex, you group these binary digits into 4s. Here, if you want to convert hex to binary, you just doing that reversely. So for example, you have a 1AF, that's a hex number. So what's the binary version for that? So 1 is 0001. You just recover these 4 digits here. A is 10, right? So 10 is going to be 1010. So don't worry about that. How I get this number here, right? So if you are more familiar with all these binary numbers, you actually know that this is going to be 10. The reason is this digit represent 8. This digit represent 2. So 8 plus 2 is going to be 10. So you know this is 10, right? But don't worry about this right now. You will be more familiar with this later. And F is 15, okay? 15, this is 15. So that's how you convert a hex number into a binary number. Okay, so now let's look at the chart, what we have done here. So we convert binary to decimal, we convert binary to hex, and we convert it to hex to binary. So now, before we start converting things from decimal to these things, we have one left, which is hex to decimal. So 6. If you have a number like 2, E, A, things like that, for example, this is a hex number. So what's the decimal version for that? So here in the hex number, 2 here is pretty similar to the decimal number, the example I just gave to you in the very beginning. So for example, this is a decimal number. So 5 here is not actually 5, it's 500, right? And 3 is not 3 is 30. 7 is actually 7. So it's same as here. It's in a hex number system. 2 here is not 2. It is 2 times 16 to the times of, so after this digit, you have 2 digits here, right? So 1, 2, so 16 to the power of 2 plus E. We know E is 14 in hex. It's gonna be 14 times 16 to the power of 1, and then A is 10. So A times 16 to the power of 0, right? So 16 times 16, now let's do a calculation here. Convert it to scientific. So 16 times 16 will be this, and then times 2, it's 512 plus 14 times 16, 224 plus, so that's 1 here, so plus 10, right? So let's add them together. 512 plus 10. That's the final number. Now we can actually verify this number really quick. See if this one is actually this one in hex. We start using the programmer version here, and so that's a 10-based number, right? And now we put it in decimal and we type 746, and now the hex number, corresponding hex number is 2EA. So we can verify that our calculation was correct. So if you look at that, before we go further, let's take a look at this. Anything from, we convert binary to decimal, or we convert hex to decimal, we're using the same strategy, okay? We use this times this, plus this times this, plus this times this, so on and so forth, okay? It's the same strategy here. So this is how you convert a binary or a hex number into decimal, okay? So now, before we wrap it up, we still have 2 things we haven't done yet, all right? So look at this. Hex, decimal to binary, decimal to hex. Now let's do it. Let's do decimal to binary first. Okay. Decimal to binary. If we have 125, which is a 10-based number, I want to convert, I want to know what's the binary number of it. Of course, you can use this, right? You can use a calculator to do it. However, we are trying to learn how do we understand it manually, okay? So I'm going to show you how I'm going to do it, and then I will explain that to you, why that makes sense, all right? So let's take a look at that. 125, when we are going to convert it into a binary number, the first thing we want to do is we divide it by 2, and we get a result, which is this divided by 2 is going to be 6, 2, and the remainder is 1. And then we divide this number by 2 again, we got 3, 1, and the remainder is 0. We divide by 2 again, divide this number by 2 again, we got 15, remainder is 1. Do it one more time, you got 7, remainder is 1. Do it one more time, 3, 1. One more time, 1, 1. One more time, 0, 1. Okay, and now you got all these 1 zeros, and then you look at backwards. This number will be the binary number for this decimal number. And now let's verify this really quick. Okay, so if we have a calculator here, and let's type this binary number. So it's going to be 1111101. So 5 1s and 0 1. 1 2 3 4 5 0 1. So if you can take a look at here, so decimal number is 125. So the calculation was verified, it's correct. So why, it's kind of interesting. So why, when we divide this number by 2 every time. We have a remainder here, and finally it's going to be the binary number for this number. So why is that? So if you look at so when we are doing a division for a decimal number, for example, still use the same one. I don't know why I like this one, but let's still use this number, right? So that's a decimal number, for example, and I'm gonna divide it by 10. So decimal number in the decimal number system framework, I'm gonna divide this number by 10. So the result will be 57, and remainder is 7. 53, the remainder is 7, right? And now we divide this number by 10 again. We got 5, remainder is 3. And we do it again. We cannot divide anything from 10 from 5. So the result is going to be 0, and remainder is 5. And we look back here, and we can recover this number. So which is really interesting. This works in that way is because whenever you divide this number by 10, in the very beginning, the decimal point is actually like here, right? That's 537. The very beginning, you didn't write it down, but actually you have a decimal point here. It's 537.0. That's the number, same number here. And whenever you divide this number by 10, you actually shift this digit or this decimal point to the left by 1 digit. Okay, you divide this number by 10 again, you move it one more time and one more time, right? And every time you move the decimal point, you got a remainder here, which is actually this digit, exactly that digit here. So when you are moving, shifting this decimal point, I like to use that word, you are exposing this every digit in that number. When you divide this number by 10, okay, in the decimal number system. However, here, right, it is 125, but in the very beginning, we don't know what the binary number is here, right? But what we know is when we divide this number by 2, we can get a result, and we can expose that digit over there. But it's not, you say, hey, this digit is 5, it's not 1. Okay. The reason is we write down this number in the form of a decimal number. So that's why it looks like a decimal number, but actually when you are dividing this number by 2, there's no difference like when you are doing this. If we write down this number here, okay. If you do it here, right? So when you divide a binary number by 2, you're actually moving or shifting this binary point to the left by 1 digit. So this one divided by 2 is going to be 11110. That's the result. And since you just shifted this point to the left, and you have a remainder of 1 because this is 1 here. Okay, this is how you get it. And now you do it again. You are shifting that point to here by 1 more time. So get this number, you get a 0. And you just keep doing that. And then you do it again here. So actually I couldn't write it down anymore. So we got a 0 here, remainder is 1. So finally, we got 1, 1, 1, 1. You look back, you actually recover that number because every time you just expose every digit from this number. Okay, we didn't write it down in this format, but actually, this number equals to that number. That's why it doesn't affect the result. You're actually exposing all the binary numbers from this original number. This is how that works. Okay, you can actually use the same concept as when you convert a decimal number into a hex number. But this is just one example here. We convert from decimal to binary, and don't worry about that. Just if you think I did it just too fast, feel free to pause the video and just rewatch it, or you can do the calculation by yourself on the paper. So it's one thing here you need to remember is please do not forget the last one. So do not stop at here. You still have a little remainder here. So you want to divide this number by 2 again. You get a 1 here. The same thing here. Do not stop at 1. You want a 1 divided by 2. You get a 0. Remainder is 1. So whenever you get a 0 here, you are done. Otherwise, just keep going. Keep dividing that number. Okay. And so now the last one, decimal to hex, right? We don't need this here. I think we have a paper already initiated here. So decimal to hex, same concept. For example, 276. I don't know. That's a decimal number, for example, and we're going to convert it into a hex version. So if you convert a decimal to hex, you are divide this number by 16 instead of by 2, right? So divide this number by 16. So let's see what is that result. Okay. We need a scientific, and then we use 276 divided by 16. So it's 17.25. It's bigger than 17. So now let's calculate it back. Let's use 17 times 16, which will be 272. So we know it's going to be 17, and 17 times 16 is going to be 272, and the remainder will be 4, right? So which means this divided by this, we got this result, and remainder is 4. And now we do it again. 1, 1, and do it again. 0, 1. Okay, so we loop back from bottom to top. So actually, the hex version is going to be 114. Now let's see if this is right. Let's go back to the programmer version, and we type a hex version here, which is 114, and the decimal version is 276. Right, so it's got verified. Let's try one more example here, so you know how to do it with this decimal to hex. So if we have a bigger number, 2,325. So what's the hex number for this number? All right, crazy, right? So now let's divide this number by 16. Of course, I couldn't calculate it just manually. So now let's 2325 divided by 16. So 145. So 145 times 16 is 2320. Okay, and the remainder is 5. No, not this number. I forgot. Divided by 16. 145. All right, the remainder is 5. Now let's do it again. Sometimes it's confusing, right? 145 divided by 16. So it's 9 something, okay? So it's going to be 9 something. So 9 times, let's calculate this back. 9 times 16 will be 144. So the remainder is 1 compared to 145, right? So now let's do it again. Of course, we know couldn't be divided by 16, and now the remainder is 9. Look it back. So the decimal number will be this. All right. Let's verify this really quick. We have hex number, which is 915, and the decimal version is 2325, which is right. So it's just verified. All right. I think we have covered all these number conversions. Now let's do a review on that really quick, right? So these are the 3 number systems have been often used in the computer when you're designing something. You need to consider, you need to calculate sometimes manually. So that's why we are doing number conversions among these three number systems. So think about that, from binary to decimal, what we did. How can we do that? Binary to decimal, right? So everything being converted to decimal, we actually just use the number as a digit and times how many this number is representing, right? So this number represents 16. That's why we use 1 times 16 here, and so on and so forth, right? So this is how you write it down. So whenever you have a number being converted into decimal, doesn't matter it's a binary, it's a hex, or it's octal, or this like some weird number system like 6-based number systems, you are actually using the same strategy here whenever it's being converted to decimal. Okay, keep in mind, same strategy. So binary to decimal, we do it in this way. So if you look at the hex to decimal, we do it in a pretty similar way, straightforward. Okay, so we are done for anything converted to decimal. We're done. You already learned how to do it. Okay, so now what about everything converted to binary? So decimal to binary or hex to binary, which is the last two examples where I gave to you. Decimal to binary, you do it in this way. You divide by 2 and you are exposing every single digit from the right to left. So decimal to binary, we did it. Hex to binary, which is either. So we just convert every single one into a 4 digits or 4-digit binary number, one by one. Then we are done. Okay. So that's hex to binary. We're done as well. What about decimal to hex? How did we do that? Decimal to hex. So we have to divide it by 16, and pretty similar way to decimal to binary. So keep in mind, whenever you have a decimal number to be converted into a hex or to other number system, you are doing this division one by one. That's how you convert into from decimal to something else. So decimal to hex is done. So what about binary to hex, which is the easiest one, almost way. Binary to hex. We did it here. Okay, we group every 4 single binary digit, every 4 binary digits into one group, and we convert that 4 digits into a hex number. If we don't have enough digits, we just make up 0 in the front. So this requires you to start from the right to the left. So starting from the right side and then to the left, whenever you don't have enough digits, you just make it up in the front. Okay. All right, we now have learned all these number conversions. So in the next video, I'm gonna tell you how do we deal with these numbers when we have a fraction, you have a fractional number there. So which means we have something after the point. How can we deal with that one? So thanks for watching this video. We'll see you in the next time.